So we're going to continue where we left off. I've got, and we're going to continue going over the final exam, practicing for the practice problems for the final exam. Okay. I will send out an announcement about the final exam. So, either this weekend or at the beginning of next week, just to remind you when it is, which is the 19th, the last possible day. Right? So we will go ahead, but otherwise we're going to go ahead and just tackle this. Okay. Come on, you can do it. All right, so we're going to start with question 5. So same kind of deal. I plan on giving you some time to tackle this problem, and then doing it. Then I'll do the problem for you. So has 2, 3, 1. I really haven't had a better name for this one, but the idea here is that you're given a list of numbers, and I want you to return true if it follows the 2, 3, 1 pattern. Namely, where we have a value x, then it's followed by x plus 1, which is then followed by x minus 1. So you don't have to print out what the numbers were, but we listed them in the example outputs for extra clarity. Okay, specifically 1, 2, 3, 4 is false because it doesn't contain this pattern. Right? It doesn't have x plus 1, x minus 1. Whereas this one has this one does. It has 3, 4, 2. So we have 3, which is our x, 4 is x plus 1, and 2 is x minus 1. So it's 3, 4, 2. Okay. And then finally we get this over here with 0, 1, negative 1 as true over here. So again, it's just, and I'm guaranteeing you that you get a list of integers here. Now remember, the first thing you're going to want to do is, let's go ahead and take and copy this into the editor. Okay. I'm going to give you a chance to work on it, but again, first and obvious steps over here is to copy this into the editor. Okay. The next thing I'm going to do is, since this is a true or false problem, it only returns true or false, I'm going to do what I always do for true and false problems that aren't just simply like, the Zor problem. Here what we're going to do is that we are going to assume 1 and then try to disprove it. So we're going to assume something that's always true, and then we're going to try to look at this and see, hey, is that not the case? So here what I'm going to do is I'm going to assume that 2, 3, 1 is false. I'm going to return false by default. And if I find something in this pattern, I'm going to return true. That's easier to prove, right? That's easier to prove, to show that there was, generally if finding one thing gives you the answer, like one instance of something gives you the answer, you want that to not be the default. And for the default to be not finding that thing. So here, the next step would then be to iterate over this in some way. So, which would mean a for loop, but I'm not going to write that for loop because I don't want to lead you astray here. Okay? So, go ahead and give that one a try for about 5 minutes. So as I mentioned, for this one, we want to iterate over it not using the for, normally our instinct to iterate is to do something like this. Okay, why'd you do that? I don't know why. To do something along the lines of for, number in R, and do something with number, right? That's the normal way we want to do stuff. But when we're iterating through and we need to compare one item to the item next to it, right, we need to keep in mind, wait a second, if I'm not careful, like over here, if I try to compare 2 to the item to the right of it, I'm going to be in a world of pain because that's out of bounds. So what we need to do is we need to have a bit more control over that. So for index in range, len r. Now, over here, this would go through all indexes over here. It would iterate through all the indexes. And what we want to do is, since we're going to be looking 2 ahead, we want to stop 2 before the end. And even without doing any math here, we can kind of go, oh, without having to abstract it at all, and I will abstract it in a second, but we can kind of go, oh, if this goes through all possible indexes, right, then doing -1 would mean that we don't go through the last one, and -2 would mean we don't go through the second to last one. So that's what we want. So this abstractly says, this goes through indexes 0 to I -1. Those are, for all indexes from 0 to length -1, right? So if it's 5, this would go from the indexes 0 to 4, and then subtracting 2 from that would go from the indexes 0 to 2, which is what we want over here. So for index in this range, what we're going to do, and this is also why we want to make sure we use good variable names, because we're going to be doing a lot of plus signs over here. For index in range, we'll say that x is equal to. We could do it as a big if statement, but honestly, that's a bit of a yuck. There's a lot of ways to do this. One is you could do it like that big if statement, which is like for r index is equal to r index plus 1. That's the next index plus 1 and r index plus 2 minus 1 r index. There we go. Return true. And that looks absolutely horrific, right? That's terrible. Why does it look terrible? Well, it's because we have this plus 1 over here with a bracket in between it. It's just suddenly killing our readability. This is completely correct, I believe, by the way. Like what I did here is not wrong. This says if the item at index is equal to the item at the next index, but plus 1, oh wait, it's not right. I'd have to subtract 1 here to make sure over here, right? So if 3 is equal to 4, then we have to subtract over here, minus 1. And array index is equal to array index, and then this would be plus 1 over here. Right? It's awful, right? So awful I even messed up on this one doing it like this. So instead, always go for readability. Readability costs you nothing in terms of lines and can save you a lot of trouble when you're just debugging. So here we're going to say that we've got x is equal to r index, and we're just going to comment out this over here. X let's go ahead and say x. What should we call this one anyway? Since it's the next item, right? Well, we could call it y. Why not? Y is equal to r. Yeah, it actually works in this case to use x, y, and z. Index plus 1. And z is equal to r index plus 2. Okay. So now we are going to ask ourselves, we're going to still do that compound statement because now they're going to be much smaller, but it should be much easier. So first off, x equals y and x equals z. This is incorrect, but it is telling us these are the formulas we want to play with, right? We're comparing x to y, and we're comparing x to z. We could compare x to y and y to z. I mean, we can do the math on there, but why? No pun intended, actually. So x is array of index. So this says here, and then we want to check if the 1 over here is 1 more than our value. Okay? So if x plus 1 is equal to y, right? If x plus 1 is equal to y, right? And we want to check if this value is we want to check if this value is 1 less than this value, meaning that this value is 1 more than this 1, which means we would subtract 1. So if x plus 1 is equal to y, and x minus 1 is equal to z. This is the same thing I did over here, but I just kind of moved the variables, I just kind of moved it. If you notice, I took this minus 1, and again, just like you would do in algebra, because that's exactly what we're doing, I just simply did that. But look at that. Array index plus 1 is equal to array index plus 1. That's not exactly a subtle difference, but it's easy to, but trying to express it verbally is not something we're equipped for. Whereas this is something we're equipped for, verbally. And if you can't express it verbally, that means you can't really put it into a story mentally. And again, humans, the way we remember stuff is by stories. That's just how we work. We love stories. Okay? And part of stories is having names, and these things have identical names even though they're completely different. So return true. Okay. Next problem. So we've gone over this one, the penny game. We did that. And we went over the Monopoly game. Happened a while ago. All right. Given a string, write a function that returns the most common letter in the string. Use the dictionary to do this. Now, was this a question on the exam? I forget. Was it exactly this question? Or was it given, what was the question on the exam? Given a string. Yeah, but it was the most common word or the most common letter? Word. Most common word. Right, we can tackle both those problems here. Okay, given a string, write a function that returns the most common letter in the string. They're both very similar. Okay. Def. No, not def. I get it. I'm tired too. So here we go. Use a dictionary to do this. So def, most common letter. I know I've done this one as a practice problem before, but I will go ahead and do it anyway. Def, most common word, and we'll look at the one that was done on the exam. So text and text. I just like using text. That way there's no confusion with, I could call it string or S, but text also just makes it so makes it understood that I'm not talking about the string type. It's just text. It's a bunch of letters and stuff. Okay, given a string, write a function that returns the most common letter in the string. Use a dictionary to do this. So to do this, we need it. This is one of those where we can just iterate straight through it, but in both these cases, what we want to do is set up a dictionary and return it. I'll call this, what I need to do in order to find the most common letter is I have to create a letter count. I have to create a count of all the letters that I have. Okay? And that is going to be stored in a dictionary. Right? That's what the dictionary is going to be doing. It's going to be creating a count of all the letters. Okay? Now, I'm going to do what this kind of the standard form for a dictionary. For in range not in range, for, not this, but for letter in text, sorry, then what are we going to do? We're going to go through those, we're going to ask ourselves if letter not in letter count. That's why I like using good variable names. It makes sense when you write it like that. If the letter is not in the letter count, if we've not seen this letter before, congratulations, we've seen this letter now. So we say letter count is equal to, letter count for that letter is equal to 1, because we've seen it once so far. Else, it's not in the letter count. Else it is in the letter count. So we first checked if it wasn't in the letter count. Now we check if it is in the letter count, in which case we just do this, the same thing, except instead of setting it to 1, we increment it by 1. Right? If you haven't seen it before, you want to say, oh, I've seen it now. Okay? And if you have seen it before, you want to increment it. By the way, it doesn't matter which order you do it in. If you do it in this order, if the letter's in letter count versus this, no difference. Right? All I did was just flip over there. It's no problem which one you do. They're equivalent. Although when I do this one next, I'm going to kind of show off how I can, how else I can do this. Okay. Now we've counted up all the letters to find out which one's the most, and now we just need to find out which is the most common one. Most common letter, most letter is equal to, and I'll use the empty string for right now, and most count. We're going to say I've seen a letter, this first letter, -1. I've seen the empty string -1 times. These are just kind of, I could do 0, but I'm just simply setting these up so that they'll get immediately replaced when I iterate through. Because what I now need to do is I iterate through for every letter in letter count. Now when we look at a dictionary, now there's a couple different ways to go through a dictionary. To iterate over it, you could iterate over the keys, you could iterate over the values, but if you just simply ask it if you just ask for thing in your dictionary, it's just going to let you iterate through the keys. That makes the most sense because you can use the keys to obtain the values, which is exactly what we're going to do. Let's see. So, letter count is equal to letter count of that letter. If count is greater than most count, then congratulations, we found this thing is the biggest letter so far. Most count is equal to count. Most letter is equal to letter. So this becomes updated as the most common letter and gives us the count over here. What's over here? Why it's not. Okay, and oh yeah, because I'm not actually using it somewhere. That's why it's return most letter. And that will give us the most common letter. So give you a second to look at that before oh wait, I can full screen this. View, appearance, full screen. No? Oh yes, full screen over there. All right. Now let's take a minute or two to tackle the one independently, to try again to tackle the one you did on the exam, back in exam 2, which is the most common word. What's the difference between this one and this one? The difference is that you're looking for whole words, which means that you're not going to be iterating over letter by letter, but iterating over each word, which means what's the first thing we need to do here instead of iterating over it? You got to split it. And on the exam, and same thing here to make it easy as I did on the exam. You can assume that there's no punctuation and words are separated by spaces. So that will make it super easy to not have to worry about, because worrying about that stuff, it's a whole separate kind of technique that you would have to worry about. Again, I try to keep things simpler on the exam so that we can just do that. So go ahead, I'm going to leave this up as kind of a basis for you, and you just modify that, and we'll quickly come back here in a few minutes. Okay, so this one shouldn't be too bad of a transition. First off, over here, again, instead of doing a letter count, we're going to just call it, word count. And that's equal to this, a dictionary. And what we're going to do is we are going to iterate through again but what are we iterating over, as I mentioned? Text.split to split it up into words. Assuming I can actually hit the right keys. Split on spaces. Call it words over here. Or word. Here we go. I'll call it list of words just to make it easier to read, believe it or not, for the next word. For a list of words. For word in list of words. That's why I went ahead and added more to the variable. Now over here, what I'm going to do is I'm going to do something very similar to what I did up there, but I'm going to say so if word not in list of words. But here's what I'm going to do instead of saying 1, and this is just a different way to do it. I'm going to do word count, instead of doing word count equals 1, I'm going to do word count equals 0. Now, why would I do that? I've seen it 0 times. Because what I'll do is rather than writing an else statement, I'll do this. Word count plus equals 1. Word count of that word plus equals 1. So whether or not it's in there already, I'm going to be adding 1. I know it. That's always the action I'm going to be performing, whether or not it's in there. It's going to be incrementing it by, either set it to 1 or increment it by 1. So I could just as easily start at 0 and increment it by 1. So I mean, that's one way to do it if you want it to be more concise, but it's also not necessary. I don't think it's actually any more efficient. But I just wanted to point out that was a way to do that. There's more than one. Okay, for word in word count, okay, what we're going to see is we're going to get most, and then we do the same exact thing over here. Most word is equal to most count is equal to 0. Yeah. For word in word count, if word, let's see, did I do that right over there? Yeah. Okay, yeah, I just simply did that as an if statement, outside of an if statement. If count is equal to, count is equal to word count of that word. If count is greater than most count, return, no, not return, what am I doing? Being silly. Most count is equal to count. Most word is equal to word. Then return most word to figure out what that will give us back the most common word. All right. So now we're going to go over one of the questions that I think a lot of students I had noped on when I gave it out in an exam a while ago. So here's a Monte Carlo from a couple of years ago. Dungeons & Dragons, D&D for short, is one of those popular tabletop role-playing games currently on the market. If not the most popular, and I'm a pretty big fan of it myself. In D&D, you take on the roles of adventurers, going on quests and slaying monsters. So for your exam, we'll be running a simulation to answer the following question, which is, what are the odds a level 1 fighter can slay a goblin in one hit? This is assuming, of course, we're just rolling dice and the DM isn't, playing people intelligently. Fun fact, if you play D&D, Tucker's kobolds. Look them up. That shows you how even kobolds can pose a threat to high-level adventurers, but that's neither here nor there. So what do we need to answer this question? Why am I asking this? Because it's a dice rolling question at heart. Dungeons & Dragons uses dice in general to figure out anything that's random. Typically, you're rolling not just six-sided dice, but weird dice that has different shapes. For instance, the most common dice we use is an icosahedron. In other words, a 20-sided dice. That's pretty much what we use for everything in Dungeons & Dragons, a 20-sided dice. First thing I need to teach you is dice notation. Yes, there's notation for dice. It's very easy notation to understand. This is the standard dice notation, which is always 1 is x dy plus z. It's not as hard as it seems. 1d20 plus 5 means that I want to roll a 20-sided die and add 5 to it. That means take your 20-sided die, roll 5. So the range is between 6 and 26. Sorry, 6 and 25, not 26. 6 and 20. That should be 6 and 25. Why? Because your lowest value is 1 plus 5, and your highest value is 20 plus 5. Another common roll is 3d4 plus 4. Take 3-sided dice. By the way, those are the worst dice on the world. Why? Because they're little pyramids, and they like double as caltrops. So, like literal caltrops, not in-game caltrops. I mean literal, don't step on these things. They hurt worse than Legos. Take 3 4-sided dice, roll them, add 4 to the result. That gives us a range of, the lowest result we could get is 3 1s plus 4. And then the highest result we could get is 16 because we could get 3 4s plus 4. So 12 plus that. And then finally, the last, a really common one, roll 6 8-sided die, roll them and sum them up without adding anything. So that gives the range 8 to 8 times 6, 48. So what we're doing for this is that we're calculating 2 rolls, essentially. The first is because combat has 2 things. First is an attack roll, and the second is a dice roll. By the way, if you were playing Baldur's Gate, this is how it works, in case you're curious, because it's built on those rules. So there's 2 rolls. One to see, basically one determines does the fighter in fact hit this goblin, and the second one, it establishes how much damage is going to be done. This sounds like a lot, but at the end, I give you a simulation over here, which is saying you do this one, see if it exceeds this number. Do this one, see if it exceeds this number. Sounds like a lot, but part of this practice problem when I gave it was to see, hey, can you take this and work through all the weeds to see if it's anything. By the way, once again, the Monte Carlo game that I have established for here, this is not understandable by toddlers. The one I have for Monte Carlo is understandable by toddlers. That doesn't mean that it's any easier. It just means the rules are very easy and straightforward. All right. So first is the attack roll to see if we can hit. For instance, and the way that works is you just simply roll a d20, and add a number. 1d20, add a modifier, see if it beats or exceeds a target number called the armor class or the AC. Example, wizard trying to blast a zombie with fire. Zombies can't dodge, so it has an AC of 8. Assuming my wizard's attack bonus is 4, 1d20 plus 4. If I roll something greater than or equal to 8, then I've hit it, and I get to move on to the next phase. Otherwise, I miss, and the damage is 0. So that's what's important for this one. We're always going to roll for an attack, but we're not always going to roll for damage. Right? If we miss, that's no damage. Okay. Damage roll, you just simply see, once the attack hits, you roll for damage. There's no real kind of check on that. You just simply roll the dice and add a bonus again. For example, if a cleric who hits a ghoul with his mace might do 1d6 plus 2 damage, which has a range of 3 to 8. While the wizard from this above example, if they're playing 5th edition, that's probably 1d10 damage. Damage is subtracted from the target's hit points or HP. If we reduce a target's HP to 0 or less, we have slain it. So simulation. We're going to simulate a level 1 fighter, in other words, a player who just started the game, attacking a goblin and calculating the odds of slaying this goblin in a single strike. The fighter has an attack roll of 1d20 plus 5, and the goblin's AC is 15. Since they're quick and they wear armor. If the attack roll hits, the fighter's damage is 2d6 plus 3. A goblin has 7 hit points. Calculate the odds of a fighter slaying a goblin in a single blow by simulating 100,000 attack rolls and their respective damage. A missed attack deals 0 points of damage. Now you're wondering what might be why, okay, how in the world was I supposed to do this if I was given this on an exam? I had a rubric right here that kind of tells you what step by step we need to do. First, create a function for rolling a d20. Next, create a function for rolling a d6, right? Those are the only ones we're going to be using here. d6s and d20. And make a function for the attack roll, code or function to see if it hits, code or function to calculate damage, code or function to see if it's slain. So we're going to follow this by going through the rubric. Why am I... Yes? When you do a critical hit? It's irrelevant because if you're doing a crit, it's going to die. You're going to be... Because on a crit, you'd be rolling double dice, which is 4d6. The minimum that you can roll is 7. I thought through this example. Very hard.
No, but like, wouldn't you still have to do that? Because if you don't double the dice, right?
You double the dice.
No, on this problem.
No, well, yeah, we don't double the dice on this problem. On natural 20s. Okay, I'm not adding in the natural 20 or critical hit rules because they're irrelevant to this. It's gonna work out regardless.
But what is the minimum damage on a 1?
It's true. We're gonna miss out. True. We're gonna miss out on that, right? But I'm not. But again, if I add any more to this, this becomes overcomplicated. It is. It's a 5% chance. But yeah. Okay. So first off, a function for rolling a d20 so let's go ahead and do that function for rolling a d20. So I'm just going to call it def d20, which rolls a 20-sided die. Also, as a reminder, got to import random whenever we're doing Monte Carlo kind of stuff, whenever we're generating random numbers. Okay, a d20. Okay, so what we're going to do over here is we're going to create our, we're going to use return random, and then we have to remember which one we're doing. Random not range is most likely what we want, because random not range, choose a random item from range, start, stop. Oh, nope, rand int includes the endpoint. That's what we want. Rand int, not rand range. Rand int includes the range, rand int. Read your documentation. Rand int 1 to 20. There we go. We want to make sure that it's inclusive, that includes the 20. Def d6. Return random dot randint 1 to 6. Right? So the next thing we want to do is write a function to make an attack roll. So let's go ahead and say def attack. So we either hit or we don't, right? So that seems like, so that's a good candidate for true or false, right? So attack. So either we're going to hit this or we're not going to hit it. Okay. We're just going to go ahead and hard code it. AC. So it says, so this is our target, rolling at or above 15. If D20 plus 5 is greater than or equal to 15, then return true, else return false. And that's our attack roll function. In fact, that's that's about 10 points right there. That's both the writing the function and returning properly, right? Because that's what we said over here. An attack roll is 1d20 plus 5. So if d20 plus 5 is greater than or equal to 15, then congrats, we hit. If it hits, then we go for damage. These days I'm playing more Dungeon World or Monster of the Week. I found that I enjoy rules light systems and more to be more abstract. I like those. Damage. So damage roll is how much? What does he do for the damage roll? He rolls 2d6 plus 3. So common mistake over here would be to do 2 times d6, right? If I tell you to roll 2 dice, some people will roll a dice and multiply it twice, but that's not what we want. We want d6 plus d6. And then it had another number, plus 3. So that's how much we roll. A d6 plus a d6 plus a 3. Okay. And then finally, we'll do let's see, what was the other thing? All right, now we have to see if it's enough to slay the goblin. If damage roll is greater than 7 or equal to 7, right? Meets or exceeds here. That's another reason. You got to read whether or not it meets or exceeds. Then return true. Else return false. And there we go. Trials is equal to, I said 100,000. Wins is equal to 0. For in range trials, if attack, actually we don't need to say if it's true, just if attack. It will either evaluate the true or false. If attack, if damage, which we can just simply summarize. And the reason I'm doing it like this, well, actually, hold on a second. I can do it like this. If attack and damage wins plus equals 1. In other words, if they both return true, return true. Why am I not concerned about, like, wasting rolls over here? Like, you only need to roll the damage if you hit. But I haven't broken them up. Yes? Yes, that's exactly correct. The default behavior for programming languages in AND statements is what's called short-circuiting, meaning that if you've got an AND statement and we check something, if it's a big AND statement and we can immediately see that one side is false, we won't even bother checking the other side because it can't evaluate to true. Same thing with the OR statement. As soon as we see one thing is true, in an OR statement, the whole thing's got to be true. And incidentally, if you're coming from another programming language, right, you may have noticed that your and statements would have looked like this, right? That if we were to write that in another programming language, your and statement, your Boolean statement would have looked like this, okay? Attack and damage, because it's going to short circuit. So now that you know that, guess what this does? Yes? No? If this is so actually not a trick question. If this is if this does short circuiting, and then what does this one do? No short circuit. That is why we use two ands, by the way, in C and in Java. If you've ever been wondering why that is, if you've done C or Java or any programming language, try it. You can try it, make your variable make your functions have a side effect, and you can see, oh, the second function's not going to get called versus the second function's going to get called, regardless. So anyway, and Python's like, that's silly. Yes? Because some code needs it. Okay, some code is weird like that. It wants you to, sometimes it wants to roll, sometimes you want, maybe like when you're updating a screen, you want to check multiple things. Yes? Was that a question? Sorry? The short circuiting is, I believe, the default behavior in Python. But in other programming languages, the way they teach you to do it is always in Java, when you learn, an and statement's going to learn like this. They're going to say this is what an and statement looks like. They're going to say that this is a Boolean and a binary and statement, which is also true. But I mean, you can do that, and I just might as well explain now why that is. Okay. Anyway, wins plus 1. And now what we're going to do is we're going to just print out wins divided by trials times 100 plus str %, and that'll give us a percentage chance. Let's see, type error for unsupported operation. Right, of course. I always forget that about this. So I love Python. This is my only qualm, because Java actually does print statements better, which is that if I want to concatenate, if I want to add something to a string, if I want to add a float in a string, it should convert automatically, but I have to manually convert it. And there we see we've got about a slightly better than half chance of doing that. Okay? Which is fair if you think about it. It's common first letter, common first enemy there. New player gets to feel good about himself by one-shotting enemies. That's good. Yeah. All right. But even things with complicated rules and complicated rule sets, if you narrow it down to what you need and follow the rubric, we find that actually it's not so bad. Follow that rubric if you are having trouble. I put it there for multiple reasons. It's there to help you. It's there to help me. It's there to be fair. Okay. Okay, so by the way, remember what I said about last time about how in some finals you would see, let me go back to that problem. I think it was like problem 3 or something over here. Yeah, it was problem 3. A sum of 3s, where I've got a list of lists and I say, give me the list of all multiples of 3. Oh, look at this. Here's another problem. It was that I said that is a good final exam practice. Give me the list that contains many listed integers. Return the sum of all integers that are multiples of 10. Might be an indication that I like problems like that. that where I have you go through a list of lists and just do a very common, if it's this, add something, otherwise add something else. Okay. Here's something a bit different. It's from my pre-COVID exam 1. Why am I bothering doing this one? Why? Because it is actually, because the turtle question actually, so I did mention that we'll have a turtle question on the exam, right? So the turtle question is going to be a bit different in the sense that what I'm going to make is that it's more of a reading question. I will have a bunch of code. It's completely obfuscated, meaning that the variable names don't make sense. And I'm going to be asking you to figure out like what all the parts do, essentially. It's not as hard as it seems because you get to download the code and play with it, so you can run the code, you can modify the variables, see what happens. But I find a valuable question because enough people do try it and get it wrong, although the vast majority of people who do try it get it right. So there you go. All right, so there we go. Which is that this is an old question I used to have. The following code needs to be completed. It's almost done, but n in the code below needs a value. Choose an n such that the output of the program is 1, 1, 2, 3, 5, 8, 13. Write your answer in the code in the underscores below. So iteratively calculates the nth Fibonacci number. So the Fibonacci number, as I explained here, is a very popular sequence in both mathematics and computer science. We like giving it to you as the first example of the recursion, as well as the first example of terrible recursion, because if you implement it natively, recursively, it's actually like exponential in terms of time to calculate. That means it's bad. But anyway, a Fibonacci number is just simply the sum of the previous two. So I defined the first numbers here being 1 and 1. So this calculates the nth Fibonacci number. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, and so on. So F11, there we go. Okay. Hopefully you should be able to read that up there. And then, yeah, we want the final output to be 13 on this one. So let me zoom in so you can see better. Okay. So we want the output, the final part of the output to be 13. So what is the nth number? So go ahead and take 5 minutes or so to work on this one, right? Here's the complete code. You just got to choose the correct stopping point, in other words, right? That's what n is. So how do you figure this one out so now for this one, I didn't give the students did this one on paper. They did not have computers, so they couldn't run it. So if you encounter this kind of question and you can't run a problem, what do? Write it down. You write it down and you go through and basically you say, okay, A's value is this, B's value is this, N's value is this. We also have a C there, but as you can see, so you write those 4 variables down and keep track of them as you go through. It sounds terrible, but it's not. So go ahead, again, take a few minutes. Pause. All right, does anybody have the correct answer? If not, I'll give you a hint. Your professor, at least on exams, it doesn't ask trick questions. When he says something does something, he means something does something. Right? Even in the scam games, I've told you it's a scam up in advance, right? So let's kind of walk through this. Okay, we've got, hold on. Yay, it's right there. Wonderful. Also, I did not know that they made quadruple A batteries until I had to recharge this. Also, good. Note if you have equipment that you need, that relies on batteries before you go to, and you're going to a foreign country, figure out how to ask for the proper size of that battery before you leave for a foreign country. So, A, B, C, and N. Okay, so N is equal to, we're starting out at 2. That's where it starts. The range is equal to 2. And so our values start at A and A. So C is equal to A plus B. That's 2. A is equal to B, so we store B in A, 1 is 1, and we put C in B. So this becomes 2. Print C, so we printed out 2. We've already printed out A and B, by the way, so that's why we've got 1, 1, 2. Okay, now we finished that part of the loop, so now we go N is equal to 3. C is equal to A plus B, so C is equal to 3. A is equal to B, so we store 2 in A. C is equal to B, we store this over here. And we don't need these anymore and we print C. So up to 4 now. C is equal to A plus B. It's going to be, A plus B is 5. A is equal to B, so store 3. Right, store 3, sorry, didn't want to erase that yet. Store 3 over there. And then C is equal to B, store 5 in here, print out 5. N is equal to 5. C is equal to A plus B, that becomes 8. A is equal to B, so store 5 in here. B is equal to C, store this in here. Okay, store this in here. Should be 8. And then finally go up to and print out the 8. Finally go and do this, which is up to 6. Okay. So now 6 is equal to, so now we've got C is equal to A plus B. So that would be equal to 13. Store 8 in A, 13 in B, print out 13. And then we're done with the loop, so NB should become 7. That's kind of where most people would get this wrong. They would put 6 because they see, I printed out 13 when it was 6. But in order to make it run and get to 6, we need to put in 7 over here to do the indexes 2 to 6 inclusively. Or, as I said, you can trust your professor who says it calculates the ith Fibonacci number. Note that there's I numbers, that the number of numbers here is 7. Reading the problem explains the problem. So anyway, but I like this one for both the reasons. That's why I put it on exam 1. Or I used to put it on exam 1. I found other ones that, I used to do things like largest digit and then over here. Okay. So let's go ahead and try. I think we've got enough time to do that. So this is another exam I had. Make username. All right. So let's see. Which of the following strings does the given regular expression match? So this is a select one of many kind of things. So this is 1 star 0 plus 1 question mark 0. Okay. All right. So let's go through this. So let's go through this one at a time. Okay. And by one at a time, I mean one answer. Basically, we want to see, does this would this be found by this regular expression? 0. Okay? I see at least 0 ones, at least no ones. So in other words, as many ones as I want, including 0, including no ones. So that's fine so far. 0 plus. That means we need at least a single 0. Being very cautious with my words here to not, So at least no 0, so at least a single 0, so that's cool so far. This means an optional 1. That's what the question means. It means either it's there or not. That's fine, perfectly. And then we have a 0 at the end. This won't work because we've had 1 0 from this thing, and we need at least 1 0 here and at least 1 0 here. So our answers need to have at least 2 zeros in them somehow. So it's not going to be that one. 0 0. That's definitely going to match. I just said needs at least 2 zeros. 1 0 1 0. That's definitely going to match because we have 1 or more zeros. We have 0 more ones at the beginning, right? We can have as many ones that we want at the beginning, including no ones. So that's great. Followed by at least 1 0. Awesome. Followed by 0 1 ones. Cool. And definitely a 0 on the end. Cool. So here we have no ones at the beginning, so we'll go ahead and start this. A bunch of zeros, that's great. A single 1 and a single 0. 1 0. And unfortunately, no. It's got to have, the smallest thing we can have is 0 1 0. The smallest thing we can have is not 0 1 0. The smallest thing we can have is 0 0. The smallest thing with a 1 in there is 0 1 0. Right? So not that. Let's go ahead and again erase those that we don't need. So now let's look at this one. 0 1 1 1 0. As many zeros as we want. 1 1 1 0 would be this. So we have two groups of zeros, right? We have two groups of zeros. We have a single 0 on the right and as many zeros as we want on the left as long as we have at least one of them. But they can only be separated by a single 1. So this won't work because there's not a single 1 between them. 1 1 0. Sorry, 1 1 0 0. So let's see. These first zeros could be caught by this. This 0 could be caught by this part. Then we have no 1s between them, and then we have a 1. So this works. And then a 1, that obviously just doesn't work because you got to have zeros in there somewhere. Describe what this above regular expression is looking for. It's looking for exactly what I've been describing here, which is which is what I said. It's a regular expression that matches 0 to an unlimited number of 1s, followed by at least 1 0, followed by an optional 1, followed by a 0. Okay, that kind of thing is not what I'm going to give you on the final exam. I just saw it and I'm like, oh, that's a good practice question to get you thinking about regular expressions. What kind of question would you be more like on the exam? Not this one. Create a regular expression that will identify all integers where the digits are in numerical order. I mean, you could do this one. That would actually be a 1. So example 1. So we create a regular expression that would identify all the digits where the digits are in numerical order. So for example, 0, 1, 4, 4, 5, 7, 8, 8, 9 should work, right? But 8, 9, 5, 3 should not. Now, this one's funny because thinking about it, so I'm thinking about this and I've learned a lot more since I wrote this question about how to be obnoxious with problems. And of course I think, oh yeah, that's a one-line solution, which is very simple. This is because we're dealing with, so which is, let's see, str. So if this is a number, so I would say, hey, if this number is equal to sorted str number, that would work, right? Convert it to a string, sort the string. You know, I love to totally make fun of me in the past. He was a bit silly. It's always the person you always used to be was very, well, honestly, that person was very stupid. You of course know everything now, and you are extremely wise and talented, and will and completely exceed the person you were in the past, and the person you are in the future is just going to be even more awesome, and certainly is not going to remember you as now as being silly. So, anyway, but this is one way to do that if we weren't using regular expressions. If you were using regular expressions, then the regular expression for this would be actually fairly straightforward. It would be using the stars. 1 star, 2 star, 0 star, 1 star, 2 star, 3 star, 4 star, and so on and so forth, right? The idea here is that you could have as many of those digits as you wanted, and as long as they were in order, right? You'd have to convert them into a string again, so but that's why I bring it up. So what kind of, that's more likely to be there. Let's see. If you are interested in doing more practice for regular expressions, okay, first off, take a look at this problem. I'm going to be sending out another PDF, basically incorporating a lot of the problems that we went over in this lecture. But here's one that I've deliberately given multiple times as a practice. I've gone over one that I've given in previous exams, but and I don't have enough time to solve this now. But write a function given a file name, creates a new file with the exact same contents as the original file, but with all the phone numbers replaced with the string private, right? And then I gave you a format as to how I'd expect phone numbers to look like, right? I would expect phone numbers to look like that. And I like that one as a practice problem because parentheses, you sometimes have to escape those to deal with that, but otherwise it's a good, that's digits and stuff. I've done social security numbers one year. I've done emails. I've done other ID numbers. So those are good ones for those kind of things. So, yeah. Any questions before I dismiss the class? Yes. I will be posting, sorry, the what? I will be posting what I've done on GitHub. But for this PDF of problems, this packet of problems, I plan on taking, as you can see, I've got a bunch of PDFs here. So I'm going to take the problems that I've went over from, I'm going to move a bunch of the problems from the other PDFs into this into one packet so I can send out a single PDF. Okay, but yes, I'm planning on sending it out at some point. For those of you who are celebrating, happy Hanukkah tonight. Otherwise, I will see you all during the final.
I just kind of need that.